Alright, welcome to the video for section 1.2. This one looks mainly about solving equations using the calculator and solving equations by hand. I'm just going to be working some problems out of the chapter or the section problem set. This is on page 106. And I'm looking at problem 19. And we have, it says use a graphing utility to approximate the real solutions, if any, of each equation rounded to 2 decimal places. All solutions lie between -10 and 10. So it is x cubed minus 4x plus 2 equals 0. Alright, so we're going to go ahead and plug this into our calculator. So x raised to the third minus 4x plus 2. And if you want your window to be between -10 and 10 without going through and setting each one, instead of doing this, you can just do zoom. And it's the 6th one down, Z standard, zoom standard. So I'm going to choose zoom standard. Alright, and the solutions to this are the values of x that make this whole thing equal 0. Alright, and those occur on the, those basically the same thing as the x-intercepts. So the x-intercepts are also the solutions to this equation. Alright, and one quick way to find the x-intercepts is to do a, go to second trace, choose 0. Alright, so we've got 3 of them we have to do. And you have to, let's do this one over here first, this leftmost solution. So I'm going to go over here, and I have to be to the left of it. In that case, that means below it. So if I'm below it, I'm also to the left of it. So left bound, yes, there you go. And then it asks for right bound. So I go to the right, which is above it, hit enter, and then guess, yes. And it's approximately, as you can see, -2.21. So one solution, and this will be the solution set, I'll just put it in a brace here, is -2.21. Alright, let's find the second one. So second trace, 0. I have to be to the left of it, so I'm just going to get a little closer to it. Above it is to the left, so enter, to the right, go down a little below it, which is to the right. Enter, and then enter for guess, and it is 0.54. Let me see if I can make this focus in a little better. It looks a little fuzzy, so hold on just a second. Hopefully that's a little bit better view. This is -0.54 approximately. And then there's one more. So second trace, 0. Am I to the left of it? Yes. And to the right, enter, enter. And it looks like 1.68 approximately. Alright, that's it. So those are the 3 solutions to that equation. While I have it, let's look at some of the other ways to solve it. Well, actually, this is cubic. I was thinking it was quadratic. Obviously, it's cubic, so that's the only way it could have 3 solutions. So we'll move on to the next one. So the next one I'm going to do is 21. And that is -2x to the 4th plus 5 equals 3x minus 2. Alright, so we can think of this as, since it's not equal to 0, for what values of x does this function equal this function, right? Well, we could graph them both and just see where they cross, and then look at the x coordinates for where they actually intersect. So let's put them both in. So negative 2x raised to the 4th plus 5 and 3x minus 2. So graph. So there's the x to the 4th problem, and there's the linear function. Alright, so we see that there's two solutions because they coincide at those two coordinates. So I'll go to second trace intersect this time. And if I want to know where they intersect over here, then you kind of probably want to go down close to that. So first curve, and notice it shows up here what curve the cursor's on right now. So it's on the y. Once I've hit enter, it jumps to the next function. So enter and then enter. So you hit enter 3 times, and it looks like when x is approximately negative 1.55, so that's one solution to this equation, and then I'll do it again for the other one. Intersect, whoops, that's not right. Intersect. Alright, so I'm going to get closer to the other one here. Alright, so enter, enter, enter. And that gives me x is 1.15. Alright, and that's it. So those are the solutions for those two equations. In the next set, it says solve each equation algebraically and verify your results with a graphing utility. So we're going to look at 37. So 2 times 3 plus 2x equals 3 times x minus 4. Alright, so what values of x will make both these sides equal? Well, it's kind of hard to tell right now because it's so complicated. So the idea here is we're going to simplify this a little bit till it's something that we can, you could simplify it all the way down to x equals, which is what the book does, or you can simplify it down enough to where it's obvious what the answers are. So let's see, what should I do here first? I think I'll distribute that 2. So that's going to be 6 plus 4x. And I'll go ahead and distribute that 3, so that's going to be 3x minus 12. Alright, so now I think I'll just subtract 3x from both sides to get the x's together. So that's going to get rid of the x's over here and put them over here, and therefore I'll go ahead and subtract the 6 from both sides. And that'll get rid of the 6's over here. So now I've got nothing here. 4x minus 3x is just x. And negative 12 minus 6 is negative 18. So it looks like negative 18 is the solution. And if we want to check that on the calculator, we would just go in and put 2 parentheses 3 plus 2x into y1, and 3 times x minus 4 into y2, and graph it. Now the solution here is negative 18, so as you can see it's not showing up here because mine only goes out to negative 10. So if I want to see the solution on the calculator, I'm going to have to be able to see further to the left, at least to negative 18, and further down. So I'm going to go to my window and change x minimum to negative 20. That's a little bit past negative 18. And I'm going to need to see down further, so I don't know how far down they cross, so I better put in something like, I'll try negative 30 to start and see what happens. Since there's such a big range here, I'm going to go ahead and change my y scale to 5, so those little dots aren't just all clumped up together on the axes, so let's see if I can see them now. See, it's even further down. I don't need to go to the left anymore, but I need to go down further. So I'm going to change my y minimum, I guess negative 50. Let's give that a shot. Oh, almost. One more time. How about negative? Let's just negative 100. Alright, there, now you can see it, right? So if I do second trace intersect, enter, 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 I get negative 18 as my solution. Alright, so that was 37. Let's do another one here, something a little more complicated. How about, let's look at 55. X plus 7, x minus 1 is equal to x plus 1 squared. Alright, so let's see, I guess what we need to do is distribute these, and I'll go ahead and expand this out. And then what's going to happen is I'll have x squared over here, and I'll have an x squared over here, and they should cancel out and be left with something pretty simple here. So to expand this out, what do? I do x squared, and then x times minus 1 is minus x, and then 7 times x is plus 7x, and then 7 times minus 1 is minus 7, and that equals, this expands to what, x plus 1, x plus 1? So x times x is x squared, x times 1 is x, 1 times x is x, 1 times 1 is 1. So I have x squared, those two can be combined as 6x minus 7, and x squared, and those can be combined to 2x plus 1. So as you can see, I have x squared here, x squared here. If I subtract x squared from both sides, they're just going to go away, so let's just cross them out. Now I can take 2x from both sides, and I'll add 7 to both sides to get rid of that and put it over here. Alright, so 6x, take away 2x is 4x. Those are gone. Those are gone, and then 7, and that's 7 and 1 is 8, so x is 2. That's it. So let's put it in the calculator. So I'll put it in as it was given. So x plus 7 and x minus 1. Also x plus 1 squared. Alright, I'll hit zoom 6 to put it back to a standard window. There's the first side, to the second side. You can see it looks like they cross right there, and that should be right about 2. I'm going to move up a little bit so I can see it a little bit better. Let's see, window, go up to 15. Wrong way. I increased my x, I meant to increase my y, so let me go back in. That's 10, that's 15. Alright, now you can see that they actually do cross right there. So second trace, intersect, enter, 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 and we get x is 2. So when y is 9, x is 2 for both of those graphs. Alright. What else? 61. So we have x over x minus 2 plus 3 equals 2 over x minus 2. Alright, so first thing you need to note that there's certain values of x that we cannot get. So for instance, x cannot equal 2 here. So I'm going to make a note to myself. Separate all this other stuff out. X cannot equal 2, right? So that's, x can be anything it looks like except for 2, because if x is 2 we get 0 in the denominator, and whatever divided by 0 is undefined, right? So keep that in mind, because the answer might come out to be x equals 2, in which case we would call it an extraneous solution. So what do we need? Well, we need common denominators, right? So what could I do? I could either, since we have an equation, we could multiply everything by x minus 2 and just make these denominators go away. That would probably be the easiest thing to do. So when I multiply this by x minus 2, so I multiply, let's see, multiply this by x minus 2, this by x minus 2, everything has to get multiplied by x minus 2, or else it won't be equal, right? It's equal now, it's balanced. So if you want to keep it balanced, you got to multiply each term by x minus 2. When I multiply this term by x minus 2, they just cancel. So I'm left with x. When I multiply this by x minus 2, I get 3 times x minus 2. When I multiply the next one by x minus 2, it cancels and I just get 2. Alright, so now I need to, I guess, distribute that 3, right? So x plus 3x minus 6 is 2. And then x, that's 1x plus 3x, that's 4x. So 4x minus 6 is 2. And then I add 6, so 4x is 8. And then x is 2, but we already said, you know, x can't be 2. So we call that an extraneous solution, right? It's not really a solution, it's just basically you get a solution for this, right? That's not a solution for this up here. Alright, so there is no solution. So the correct answer is there's no solution. Let me check my book and make sure that's right. 61, the answer isn't showing up, but I really think that is correct. Now we could graph it and see, right? So if I go into my calculator, the way I would graph this is, I'm going to put this on one side, so that's going to be x over parentheses x minus 2 plus 3, and the other side is going to be 2 over parentheses x minus 2. Right, let's see what that looks like. Zoom 6. It's hard to tell what's going on here, right? Let me change one of these. So the second one I'll make different. I'll make it bold so you can see which is which. So the first equation is going to have a thin line, and the second equation is going to have a bold line. Alright, let's try it again. Here's the first one. This is 2 parts, right? Here comes the second one. Alright, so it looks like it's touching. So let me get over there, and I'm going to zoom in on it. So I'm going to zoom in on this area right here, which is around 2, right? So let me zoom in. Alright, so it's hard to see. I need to see down further, don't I? So I'm going to go to my window and look down to maybe -5. Oh, see though, it's not really crossing, is it? So if I go down a little further, how about -10? So it looks like, it really looks like they're touching. So if I scroll down there, let me zoom in on that. Zoom in, enter. You see? So where it just looks like they're so close. They're getting infinitely close to each other. They're kind of like asymptotes to each other, but they never cross. The asymptote is really occurring. There's this like invisible wall at x equals 2, right? Zoom 6. So right here, there's like an invisible wall, and that they're not going to cross, and they're not going to touch, because x cannot equal -2. I mean, x cannot equal 2. So the two graphs, and the same thing's going on up here. Even though it looks like they're intersecting, they're really not. So there is no solution. So that was 61. Let's try 71. So it's 4 over x minus 2. So again, x cannot be 2 equals -3 over x plus 5. So that means x cannot be -5 plus 7 over x plus 5 and x minus 2. Alright, so it looks like the common denominator to this one is x plus 5 times x minus 2. I need them both. If I multiply this by x plus 5, x minus 2, those are just going to cancel out, leaving me with 7. Alright, then I'll multiply this by the same thing, x plus 5, x minus 2. And x plus 5's will cancel, but the x minus 2 will remain and get multiplied to the -3. And then we'll multiply this also by x plus 5, x minus 2, and the x minus 2's will cancel, leaving me with 4 times x plus 5. So let me rewrite it. So that's 4 times x plus 5 equals -3 times x minus 2 plus 7, because everything canceled out over here except the 7. Alright, so now we have a linear equation on each side, so this should be pretty simple, but remember, we said that the domain is basically what x cannot equal 2 or -5, right? So x cannot equal those two numbers. So let's see what we get here. 4x plus 20 equals -3x plus 6 plus 7. So 4x plus 20 is -3x plus 13. Okay, so now I'm just going to add 3x to both sides. If I add that 3x to both sides, that's going to give me 7x over here. And if I take away that 20, what's that going to give me? -7, I guess, right? So 13 minus 20 is -7. So x is -1. And I'm going through this lead like crazy. I think that's about it. Yep. I'll use this. Nope, that's not going to work. Red pen it is. X is -1. Alright, so that's 71, and make sure that's right. Of course, it doesn't give me an answer, so. But we could graph it and see. It's going to be quite complicated, though. I think I'll just save that for, well, let's go ahead and graph it. Try to do it quickly. So 4 over x minus 2, and then the other side is -3 over parentheses x plus 5 plus 7 over, and then I'm going to do a double parenthesis here. So that's going to be, to make sure I enclose the whole x plus 5, x minus 2 in the denominator. So x plus 5, x minus 2, close, close. Alright, and I'll do the same thing. I'll make that second equation bold so we can differentiate between them. That's the first one, and this is the second one, and you see that they do cross, right? They cross right here at -1. And I believe that's it. Right here it looks like they cross, but again I believe that's the asymptote that they're both approaching at 2. So they can't cross there. Since they both sides have an x minus 2 in the denominator, they both share that asymptote of that vertical wall at 2. Alright, and that's it for this video. I'll pick up the rest of it in the next video. Thanks for watching.